Hello, good evening. How is the family and everyone? Hope they are all doing well. Okay, today we'll be on the part 4 on the NDT series. We're talking about discontinuities and defects. And like I rightly said last time that we are on NDT series. Understand? So once we are done with the NDT series, then we'll move down to pressure testing series. Then from pressure testing series, we'll move down to cathodic protection series. From cathodic protection series, then we'll move to the other ones. Understand? But currently now we are dealing on just the NDT series. Please, I would really like us to subscribe to our YouTube channel, like and subscribe so that anytime we post any content, you can easily get the information. Understand? So today is the part 4 on the NDT series. So today we'll be talking about discontinuities. I'm talking about discontinuities. Don't mind my drawing, please. Don't mind it. We'll be talking about discontinuities and defects. This is what we'll be talking about today. Please hold on. Please hold on. So we'll be talking about last time we talk about. You also summarize. Let's just start from. You also summarize. Last time we talk about on relating to manufacturing of all these materials. So let's just go back. Let's glance backward and see, just to summarize it before we continue for today's topic. We talk about materials and manufacturing bases, ferrous and non ferrous. We talk about ferrous and non ferrous material. We also talk about heat treatment and processes. Then we talk about welding processes and discontinuities. Then we talk about casting, forging, and rolling defects at the last, which is chapter 3. Understand? So today we're talking about on the chapter 4 on, on the chapter 4. Today we'll be talking about discontinuity and defects. Understand? We're talking about discontinuity and defect, of which we are going to talk about the surface versus internal defects. We're going to talk about planar and volumetric discontinuities. Then we are going to talk about causes of defects during manufacturing services. Please let's stay tuned. Please, I would really like us to also recommend this channel to as many that really want to have the idea and also to take NDT as a discipline. Also recommend the channel to him or her. Understand? It will really help them a lot. Like I rightly said earlier on that we are going to talk about feed discontinuities. Okay, let's just dive. I don't want this video to be more than 20 minutes to 30 minutes maximum. So please just live just to save time. What is the meaning of discontinuity and defect? What is discontinuity? What is discontinuity? Like a discontinuity is any interruption in the normal structure of a material. It's known as discontinuity. Okay, let me just don't mind my drawing now. Okay, I just want to sketch something else. Please don't mind the drawing. But I want to sketch something here just to explain this discontinuity. Don't mind the drawing. Don't mind the drawing. Okay, these are our welded joints. These are welded joints. So when you talk about discontinuities, these are the weld joint. Then we have some defects. Example, lack of fixture. We have slag occlusion. Don't mind the drawing. Slag occlusion. I'm just setting an example. Understand? All these are discontinuities. Understand? All these things now stand as an interruption to the world, like what we rightly define now. A discontinuity is any interruption in the normal structure of a material. It's not a discontinuity. Understand? All this lag occlusion, lack of fissure, bond through, porosities on the welded joint, all these are discontinuity. It may be change in shape. Like example, like what I was explaining, talking about change in crack, pore, inclusion, cavity. All these are discontinuity. You understand? So it's very important we know what is going on. Anything that interrupts the weld, any interruption in a welded structure is known as discontinuities. So please, it's very paramount we take note of this. Understand? So note every discontinuity is not rejectable. Where I see most new being in NDT feed, normally they assume that all discontinuity are rejectable. Understand? Which is very wrong. Not every discontinuity is rejectable. Understand? In every, just like as we have, okay, let me use, sorry, I will use Nigeria as an example. I believe there are laws and regulations that govern Nigerians. Understand? Meaning, if you kill somebody, either you are sentenced to prison, or depending on what the constitution states that, understand, if you are victim of it, understand, you'll be exposed to that based on the law being placed on ground before now. Understand? The same thing is the same thing happen in the field of NDT. Understand? Before you call a discontinuity a defect, understand there's a code of operation, a code of standard you judge from. For example, let me use for example, now API level for stated that every lack of penetration once is above 25 in every 4 inches length, every 4 inches lead width. Understand? Is rejectable. I don't know if you get. So the same thing is being that meaning if you exceed that 25.4 is bound to be rejectable. I don't know if you get. Understand? So you can't call a discontinuity a defect. It's not yet a defect. Understand? It becomes a defect when it's unacceptable with the code of operation. Okay. Another example I will also state now. Okay. For example, your car. Understand? You bought a new car, for example. Then unknowingly to you, there's a scratch on the car body. You understand? That become a discontinuity on that car. Understand? Then, for example, again, you bought a new car again. Then you have an issue with the engine, which is you saw there's a crack on the engine. That becomes a defect because now you watch the grip because discontinuity on that engine where there is crack. One, you can either break down the vehicle down, understand, because it's very important. Without that engine putting in proper order, it can break down the vehicle. Why that scratch cannot break down the vehicle? Understand? It's a discontinuity. Both of them are discontinuity, but one is more dangerous than the other one. That is for that of the vehicle. The same thing goes with talking about discontinuity and when it becomes dangerous to the material in question, it becomes a defect. Or if it's beyond the acceptable limit, it becomes a defect. I believe I explained in a way you understand. So the next one we are going with, which I already explained it, therefore so we will not waste time here. Talking about defects. A defect is a discontinuity that exceeds acceptance code limits and can affect services performance, like what I rightly said now. Understand? It becomes a defect when it's dangerous to the when it's dangerous to the equipment in itself. Understand? Become like the example we make mention of the vehicle now. Understand? A discontinuity we will find within the engine as is different from the discontinuity we will find within this, like a scratch in the door. Understand? Because that scratch in the door will not affect the vehicle. Unlike that engine, when there's a crack in the engine, there's every possibility that if that vehicle is not put to order, it can break down that vehicle. Understand? It's no if that engine type becomes a defect. I don't know if you get. Understand? It's very small pour may be acceptable, but a long crack is rejectable. Understand? Why on this place? Okay, let me explain crack. Just like you have your wall, the wall of your house. Sometimes you see cracks on the wall. Understand that crack you see on the wall. If you don't arrest it with time, that crack will be finding expression. Understand the same thing goes to every material we are inspecting. Understand beam pipe. If there is a crack, cracks can easily expand. Understand? So it's very paramount when you see crack, it's rejectable. You arrest it, you recut that wet and rewet back. I believe I explained. I believe you will understand it. So talking about industrial rule, all defects are discontinuities, like what I said last time. All defects are discontinuities. Understand? But not all discontinuity are defects. Meaning not all discontinuity, not every discontinuity you see you call defect. Like you want I make example of the car crash on the car door and from the a crack on the car engine. They are two different things. Understand? Not all discontinuities are defect. Understand? So let's take note of that. It's a rule of thumb in the industry. So okay, simple demonstration. We have sorry, let me zoom see what if I can zoom out for us to see this thing. Okay, this thing should be okay. Let me zoom out. Okay, this should be okay. Okay, let me take in. Okay, I believe we are seeing it. So we have crack, we have porosity, we have void, we have crack. Just all these are surface. You can see this thing visually and by the help of a magnetic particle inspection or by the help of the penetrant inspection. You can see all these are discontinuities, but it becomes a defect if it's beyond the acceptable limit. Like crack is already a defect. Understand? Normally, if I see crack in a word, I don't like some code accept it to like some code API level for accept some minimal cracks. But for me, out of experience, once immediately I see cracks, I don't accept it. I just bet it with reject because I know crack elongates. I can easily expand. Understand? So a crack is already a defect, but porosity you judge it with the standard. If it's beyond the acceptable standard, then it become rejectable, it becomes a defect. But all these are discontinuities. I believe we are getting it. So talking about surface versus internal defects. What are surface defects? So what are surface defects? These are defects open or visible on the surface, like as the name implies. You can see it visually, or you can also see it with the help of you can see with these methods. Talking about surface defects. You can see it with this method visual inspection, penetrant testing, magnetic particles testing, MT. You can, with the help of this one, you can able to visualize surface inspection. Are we together? Like what I said, I don't want the class to be more than 20 to 30 minutes. So you guys will bear with me. I'll be a bit faster. Example of surface defects. You have the crack. Very dangerous because crack can grow under stress. Like what I said, cracks can go under stress. Cracks can grow under stress. So it's very paramount to take note of crack. I always strongly suggest that once you see crack, reject it. Understand? Because cracks develop faster, they can expand easily. Understand? Another thing again, we have the undercut. All these are surface talking about discontinuity that you can see in the surface weld or in the surface of the pipe, groove at weld edge, overlap. You can see it visually on the surface aspect of it. Surface porosity, visible gas pool. You can see it. Understand? These are surface defects. Then, okay, let me bring it again. Similar with the last picture, but a bit different. Like you can see scratch on a, on top of the pipe. These are surface defect demonstration. You have the dent. Understand? Aspect of maybe the welders are grinding. At the course of grinding, they mistakenly dent the side of the pipe. These are dents. We have the corrosion. We have the bore. Understand? All these are surface discontinuities. It's not a defect yet, or except you subject it to the code of operation. If it's beyond the acceptable standard, then it becomes rejectable, it becomes a defect. Surface defect often becomes starting point for failure. S- Sorry, undo become a starting point for failure, especially in pressure vessel, pipeline, pipeline, and rotating equipment. Internal defects. These defects are below the surface and cannot be seen directly. They require ultrasonic. This way, when you talk about internal defect, your visual eye cannot just see it in the surface. It's not on the surface. Understand? It's inside the pipe. Understand? So you need the aid of another NDT method, which is you have the ultrasonic testing, the radiographic testing to detect the internal defect. Understand? You can it's not found at the surface. It's mostly found in the internal aspect of the pipe. Example of internal defect, we have the internal cracks, we have the slag occlusions, internal crack, slag occlusion, lack of fixture, we have the internal porosity. Understand? Why internal defects are dangerous? Excuse me. Because component may look good outside but fail internally. Understand? Just like how will I put it? Okay, let me borrow the word hypocrite. Understand? Just exhibiting appearance and inside of you have an evil intention. Just like that is one way I will also protest the eternal defect. Good outside, but bad inside. Understand? So it's very dangerous. So that's why we pay close attention and carry out the necessary inspection on those ones. Then we have number three here talking about planar and volumetric discontinuities. This classification is very important in weight evaluation. Planar discontinuities. Planar discontinuities. Planar discontinuity. Planar defects are thin defects with length and width but very small thickness. They are dangerous because stress concentrates easily. Easy the cracks, lack of fixture. Okay, let me just screw the example of planar discontinuities. These are the example of planar discontinuities. We have the crack, the lack of fixture, the lack of penetration, lamination. All these are planar defects. They can easily tear. So we pay close attention to it. Why planar defects are dangerous? They grow rapidly under load. Like what I said, they grow rapidly under load. Understand? They easily tear. Very critical in pressure equipment, pipeline, and structural weight. These are planar defects. Then UT importance. Ultrasonic testing importance. Planar defects usually reflect ultrasonic stance strongly. This is why UT is excellent for planar defects. Understand? Easily detect cracks. While we have the volumetric discontinuities. Volumetric discontinuities. Volumetric, for example, you bought bread. When you talk about volume, I just want to explain something. Don't mind me. You bought normal bread. Then inside the bread, see the bread now. Everywhere is smooth at the surface. But inside there is a hole, there's a void, there's a space inside the bread. That is known as volumetric discontinuity. Understand? So this occupies space. Example of volumetric discontinuity, you have the BT, porosity, slag enclosure, shrinkage cavity. The BT is under porosity, all these are porosity family. Then we have the slag occlusion, slag occlusion. Then we have the shrinkage cavity, concavity. Understand? All these are void inside, internal. All these are internal flaws, but inside The surface might seem as if it's good, but there is hole inside. It's known as volumetric discontinuities. I believe we are getting into why volumetric defect behave differently. Why do volumetric defect behave differently? Stress concentrate usually lower than planar cracks. So some small volumetric defect may be accepted by code. ROT importance. Radiographic testing detects volumetric defect very well because density change show clearly. For then, please hold on. Don't mind my course. So, saying number four, we have the causes of defect during manufacturing and services. This is number four subtopic. Causes of defect during manufacturing and services. What are the causes of defect during manufacturing? What caused it? What are the easily what bring about discontinuity at the cost of manufacturing? This is very important because defect origin. This is very important because defect origin helps inspector understand what method to use. Manufacturing defect. Defect formed during production, during casting. These are the defects formed during casting. We have gas trap, we have the uneven cooling, we have the shrinkage. During casting, these are the defects we mainly see. Gas trap like porosity inside the pipe, uneven cooling, when it did not cool randomly, like everywhere there's no like the cooling was not proper, like it's not well arranged. Understand? It cools some side is cooling while some side is hot. Understand? It's not as uneven cooling. Understand? Shrinkage. So these are defects discontinuity mainly find on during casting. Then defects, blow holes, shrinkage cavity, cold shot, causes gas trap, uneven solid to say shrinkage. Then we have defects, blow holes, shrinkage cavity, and cold shot. Then during forging, defect relating to forging. What are the causes during forging? Improper temperature, poor hammering. Then defect that mainly seen on the course of forging, we have the laps, the cracks, and the burst. So that we hurry up. I don't want to take our time. We have during rolling, causes inclusion stretch in rolling direction, lamination and seam. During welding, defect relating during welding or discontinuity. I will use the term discontinuity, it's not yet a defect. Most common source of industrial defect causes poor current setting, wrong electrode angle, dirty surface, motion, fast cooling. Defect. We have the crack, porosity, slag inclusion, lack of fusion undercut. All these are the aspects of during welding. All these are the flaws and discontinuity we have during welding. Services defect. During your call during or after equipment begins operation. Cause during services corrosion, material loss due to chemical attack, fatigue, rep- repeated loading causes crack, creep, high temperature long time causes damage, erosion, fast fluid removing material. Then we have stress corrosion cracking. Then we have combined stress corrosive medium. Example in oil and gas, pipeline may develop internal corrosion, external corrosion, and fatigue, crack near weld. All these are corrosion during service. Industrial comparison, manufacturing defect, service defect, made during production, service defect, developed during operation. Important NDT practical notes. Before inspection, inspector must ask, is defect likely from manufacturing or servicing, because this determines the inspection method and acceptance criteria, repair decision. Teaching summary: surface defect, visual testing, penetral testing, and magnetic testing. Internal defect, ultrasonic testing and radiographic testing. Planar defect, high danger. Volumetric defect, volumetric defect, density based evaluation. Code and standard specifications. When you talk about code and standard and specification, this standard, like what I said, you judge with standard before you accept or reject any any anything. So there's a duplicate there. So we are done for the class today. So the next class we'll be talking about code, standard, and specification. Understand, this is what we'll be talking at. Understand on the acceptor criteria of it. Please do well, like and follow our channel. I also recommend our channel to others to follow. God bless you. I believe whatever thing you don't understand, please do well. Send me a DM, ask your question, and we certainly will give you a reply. God bless you all. Enjoy your day.